Welcome to Energy Talks, a regular podcast series with expert discussions on power system testing topics. My name is Scott Williams from the podcast team at OMICRON, and I will be your host. Hello, everyone. Before we begin with this episode, I would like to tell you about a new feedback feature on Spotify. If you listen to Energy Talks on Spotify, you can now give us feedback and ask us questions about each of our episodes. So if you are a listener on Spotify, be sure to take advantage of this new feature and ask us anything about a discussed topic, or let us know what you think about this and other episodes. Of course, you can always send us your questions and feedback to our email address, podcast@OMICRONenergy.com. Thank you to all of our listeners who have already contacted us. In this episode, we talk about blackouts. Blackouts, or unexpected electrical outages over large areas of a power network, are a major concern for electrical power utilities around the world. There are several factors that present a risk for blackouts, whether it is severe weather or wildfires that damage important power system infrastructure, the malfunctioning or wrong operations of parts of the power system, or even wars and terrorist activities such as cyber attacks. Joining me in this episode to talk about this topic are OMICRON application experts Friedrich Almer and Daniel Wiesner. They both work with power utilities to support them in their mission to ensure a stable and reliable power grid despite the growing complexities of power systems, such as the integration of renewable energy sources and digitalization. Friedrich and Daniel discuss the various causes for blackouts and how power utilities not only plan and train for such events in order to respond quickly should they occur, but also what they are doing in terms of prevention, such as the implementation of cybersecurity in their digital networks. My guests also highlight the importance of power system diagnostic testing and monitoring to ensure that critical power equipment, backup equipment, and emergency systems are performance-ready and available to the power system when needed. Lastly, they describe how OMICRON helps utilities in this way by providing them with diagnostic and cybersecurity solutions to reduce risk and increase readiness. Hello, Friedrich. Hello, Daniel. Welcome to this episode of Energy Talks.
Hi, Scott. Nice to be here.
Hello, Scott. Thank you for having us.
Thank you again for joining me. First of all, let me ask you, what is a blackout and what are the consequences for a population?
First of all, it is important to differentiate between a blackout and a normal power outage. We define blackouts as an unexpected and sustained or longer-lasting supply outage, which affects more territories, national or even transnational. On the first glance, it might seem similar for the population, no electricity, right? But the dimension of a blackout is different to a power outage, because if there is a wider range affected, then it's not as easy to find a place with a power supply to get, for instance, groceries or medication or something like this.
Very good. Okay, thank you, Friedrich. What are the risk factors for blackouts, and how does the growing complexity of energy systems play a role in that?
So first of all, for a stable and reliable electricity supply, the generation of electrical energy has to equal the demand at any time. And if the system is in disbalance, we have a system frequency of 50 hertz or 60 hertz, depending on in which country you live. Now, if the generation and the consumption differs, it results in a changing system frequency. So if the generation is too high, then the frequency increases. If the demand is too high, the frequency drops. We are very dependent on these 50 or 60 hertz since a lot of machines and devices rely on it. And also the generators and the power plants, they are designed for a certain frequency range as well. Now, with the so-called centralized generation, large-scale power plants generate the required electrical energy, and those power plants can be also quite far away from the consumers, can be connected with long transmission lines. And in this case, we have quite simple unidirectional load flows from the generation to the consumers. And in many countries, this has changed or is changing to a more distributed generation. So meaning less of the large-scale power plants with rotational energy, and instead a lot of smaller distributed infeeds, especially from the renewable energies such as photovoltaics, wind turbines, and hydropower. And this renewable infeeds in all sizes with bidirectional load flows across the different voltage levels. So you could say that the system has become more complex, and there is a certain volatility in generation and a volatility in the loads as well. And you can imagine that maintaining the system balance and the 50 and 60 Hertz frequency has become more of a challenge, especially for days or hours with a high energy demand and with maybe less sun and wind. And we are combined with further reasons and incidents. This can potentially lead to outages or even in the worst case to blackouts as well.
Okay. So Daniel, what could be possible solutions for the challenges which come with a high integration of renewable energies?
Yeah, so basically the big challenge is how to store the energy from the renewables to prevent these grid instabilities and to thereby prevent blackouts. And yeah, there's a lot of research and development ongoing in this field. So the technology of battery storage systems has improved a lot, and there are more and more battery storage system installations as well. And yeah, we have here really also a lot of interesting projects where electrical energy is transformed into other forms of energy and possibly transformed back as well. So for example, with power to gas, there is excess or off-peak power converted into hydrogen gas, or with power to heat, where the electrical energy is transformed into heat and possibly back as well. Or also mechanical energy storage is a topic. And also the usage of electrical cars as battery storage is considered as well, or even to use the used old car batteries in large battery storage systems, and this everything to stabilize our grids. So you can see that there's a lot going on in this field, and besides the storage, also the infrastructure needs to be expanded to be able to handle the changing load flows and the increased power demands. So this means that also there are additional transmission lines, cables, transformers, and so on for the development of our transmission and distribution grids required as well.
Okay. Thank you, Daniel. What are further risk factors for blackouts?
As Daniel already mentioned or just mentioned, one risk factor is the balance between the power generation and the consumption. In addition to that, weather conditions play an important role because the consumption of the energy is higher when it's too cold or even when it's too hot because of the heating and cooling systems. And then, of course, everything that harms the infrastructure directly, for instance, is a risk factor. Natural disasters like earthquakes, tornadoes, a lot of snow, or sabotage acts are also a factor, like cyber attacks, terrorisms, or infrastructural attacks. And the last risk factor are, of course, device failures and human errors.
Okay. Friedrich, are there regional differences in these risk factors when we talk about the entire world?
The main risk factors are everywhere quite similar, but the probability of occurrence varies. For instance, in an area where already load shedding had to be established, the probability of an infrastructural breakdown due to overload and instability of the energy system is much higher. Or in countries involved in a war, the probability of cyber attacks and terrorism acts to damage the infrastructure is higher.
So power grids around the world are quite extensive. For example, can you describe how the European grid is set up?
So we have a synchronous grid of continental Europe. So basically one grid for complete Europe, including Turkey, but except Great Britain and Ireland, and also except the Nordic and Baltic countries, which have their own grid and which are interconnected with HVDC, so high voltage direct current links to the European continental grid. And as we discussed earlier, also in this grid of continental Europe, the power generation and consumption needs to be in balance all the time for the so important 50 Hertz system frequency. And there can be load flows all across Europe. For example, if there is power required in Germany, it can also come from Spain or from Greece, or depending on where the power is generated and where it is required. And also incidents in one country can have an effect on the complete European grid. So the transmission system operators of all the European countries really have to work closely together to keep the grid stable. And in the past years, we've seen some stress tests of the European grid, but luckily, larger blackouts are very, very rare.
So, Daniel, how equipped is the European grid to prevent widespread blackouts, or is it?
Yeah, I would say it is. So there's always a certain generation reserve available to react on changing demands and also to react on further incidents. So in the grid, we have so-called fast dispatchable plants, such as pumped storage hydro or gas power plants, and they are used for load and for peak matching. So peak matching meaning there's a short period of time with high consumption than available. And those power plants then quickly increase their generation to stabilize the grid. And this also if there's a low infeed from non-dispatchable energy sources such as wind or solar. And also energy can be imported from other grids such as the UK or the Nordic countries, and this on demand and on availability. Also, there is a N-1 or N-X criterion, meaning that the grid shall be able to handle single outages of, for example, transmission lines, of cables, of transformers, etc., without power outages. So there's always a certain redundancy in our system. As well, the European grid or the companies there, they train this scenario of a blackout regularly. Here also OMICRON accompanied several utilities during so-called black start and grid restoration tests. So we provided their devices and expertise for synchronous distributed measurements on several critical points of the grid. And as mentioned, those scenarios, including widespread blackouts, are trained and prepared thoroughly by the responsible companies. And I think we can say that in Europe we have a very stable grid, very few outages, and are very well prepared also for possible blackout scenarios.
Okay, very good. So if there is a blackout, what can be done and how quickly can the power grid supply electricity to various households and businesses across the country or region? How does this work?
That highly depends on the possibilities of the local grid and, of course, on the cause of the blackout, whether critical components got damaged, for instance. In Austria, we have power plants which are, as Daniel also already mentioned, black start capable. That means these power plants can start and operate without an external supply. In simple terms, it works like this. First, the controlling system is powered by an emergency power supply like a battery or fuel-powered generator. Next, the turbine must start turning. In the case of an hydroelectric power plant, we have water flowing through the turbine. You can imagine this works like a water wheel connected to a generator. After the generator starts, the supplier can begin rebuilding the electrical grid with the first loads, like lines, transformers, or even first consumers, and step by step synchronize more power plants and more lines, more transformers, more consumers, and so recreate step by step and stabilize the electric grid. Here also, the balance between the generation and consumption plays an important role again.
Okay, so how does the diagnostic testing of electrical assets help operators ensure a safe and ongoing reliable operation?
First of all, it is always good to know the current condition of the components within a critical infrastructure like the electrical energy system. Therefore, system providers make use of different inspection and maintenance strategies depending on the type and the importance of the components. The importance of the components are defined by different criteria and could depend on the type, the price, the voltage level, the location, and the supplied customers, and so on. The least effort are event-oriented strategies, not really critical components. There you only invest time and money when something already happened and you don't have an inspection or maintenance interval. Then there are classic time-oriented strategies. For instance, you inspect and maintain the components on fixed time intervals. For instance, all 4 years, you test if your protection system works properly, or all X years, you maintain your transformers within your grid. And lastly, there are the condition-oriented strategies. Here, you first inspect and then maintain depending on the condition of the component. The inspection to assess could be done in a time interval, but for really critical components, it is more common to use monitoring systems, which can detect and report condition changes automatically.
Very good. So how is OMICRON involved with the diagnostic testing and monitoring of electrical assets?
Yeah, so OMICRON provides advanced diagnosis and testing solutions for basically all the electrical assets, including power transformers, rotating machines, circuit breakers, cables, protection relays, and so on. And also we have solutions for permanent and temporary monitoring for many assets as well. With our advanced solutions, we can detect issues in the electrical grid early, before anything, including in the worst case, a blackout happens, and hence contribute to a stable and reliable power grid. Also, we have experts available all the time. So, for example, with our technical support team, which not only provides support for our devices, but also, for example, provide help with the interpretation of test and measurement results. Then we have training centers in several regions and countries to train the personnel of, for example, utilities. And this not only in the usage of our devices, but also for example, for comprehensive training courses, for the education of protection engineers, or for rather new technologies like the IC 6150 protocol for substation communication, or also cybersecurity trainings as well. And furthermore, we provide consulting and engineering services as well, including on-site measurements and on-site expertise. So I would see OMICRON as a reliable partner for utilities and companies which are in the critical infrastructure and which are responsible for our stable supply with electrical energy.
Thank you, Daniel. So you mentioned cybersecurity. How can the use of cybersecurity solutions help prevent blackouts?
Yeah, so state-of-the-art substations, they include large networks and a lot of digital communication. And cybersecurity is becoming and has become more and more of an important topic. We can also see several new national and also international regulations, including cybersecurity requirements for a critical infrastructure. So this is really seen as a potential risk for blackouts. And OMICRON developed here an intrusion detection system called Station Guard, which detects cyber attacks early so that corresponding countermeasures can be taken before any damage happens. And during the development of this Station Guard system, we benefited a lot from all the expertise and knowledge we have on how the substations, including all the electrical assets, work, and also the communication protocols used in the substations. So this solution is really tailor-made for OT networks in substations, and we can see more and more installations of Station Guard systems in our industry.
Very good. So where can our listeners get more information about these OMICRON solutions as well as training in these areas?
Well, I would say have a look at our website. You will find a lot of information there, including free webinars, also further details about the OMICRON Academy trainings as well. Then also we have a YouTube channel with really a lot of interesting videos. And please do not hesitate to get in contact with us at any time. We have 24 OMICRON offices around the globe, also a lot of partner companies in many further countries. So I would say just get in contact with us, and we are very, very happy to help and to provide further details.
I have one question for both of you. How did you both get involved with this topic of blackouts and blackout prevention?
Yeah, so I would say it's really one of the big topics of our industry. You can see it in all the events, in all the discussions, and also I have regularly here discussions and meetings with our customers as well. And in my role, I can also help the utilities to find the best solutions to assess the conditions of their electrical assets. So I would say that's how I'm involved in the topic most.
Very good. And Friedrich, what about you?
For me, it started at the university. During that time, the topic blackout was also kind of present during some lectures, and it really interested me. And then I got in contact with different suppliers and energy suppliers, and they also talked about their strategies, how to prevent blackouts and what happens if we have a blackout, also with the black start capability, for instance. And of course, we also, our government in Austria also provides blackout brochures, for instance, in some countries and some regions, what to do when a blackout happens or what you need to have at home and what doesn't make sense. So that's how I get involved on a daily basis or weekly basis.
Friedrich and Daniel, thank you very much for joining me for this conversation about preparing for, and most importantly, preventing blackouts in power grids.
Thank you very much, Scott, again, for having us.
Thank you, Scott. Bye-bye.
Thank you very much. Take good care. And a big thank you to our audience for listening to this episode of Energy Talks. If you like what you hear and have not done so already, please be sure to subscribe to Energy Talks on your favorite podcast platform to never miss an episode. We always welcome your questions and feedback. Simply send us an email to podcast@omicronenergy.com. Also, as mentioned earlier, if you listen to Energy Talks on Spotify, please be sure to take advantage of their new feedback feature and ask us anything about a discussed topic or let us know what you think about this and other episodes. Omicron has several years of experience in power system testing and offers you the matching solution for your application. This includes innovative diagnostic, monitoring, and cybersecurity solutions to help you reduce risks and be most responsive to unexpected events in the power system. For more information, be sure to visit our website at OMICRONenergy.com. There, be sure to look under Applications to find matching Omicron solutions. Knowledge sharing is very important to Omicron. On our website, you can also find the latest papers on various power system testing topics, upcoming seminars and events, as well as training courses. Please join us to listen to the next episode of Energy Talks. Goodbye for now, everyone.